Go ahead. Okay. Now I can hear myself. Well, hello, and welcome to this talk about going reactive with Helidon. We're not only going to actually go reactive, we're going to explore a little bit more. So you probably know what company I'm working for if I'm showing you this slide. So whenever you do your business decisions, please consider, if something has changed. So this is like, okay, my name is Dmitry. I work for Oracle, so you can easily find me on this address or on this Twitter. So whenever you have some questions, just tweet me or write me. I'll try to answer it as fast as I can. And I'm also from the Bulgarian Java user group, so I'm very happy to be finally on, I would say, a real event, offline event here in Coimbra, first time in Portugal, so great pleasure to be here. So we're going to explore what actually Helidon is for those of you who don't know. We will actually see this, the most powerful part of it, because on the previous JNation, which was online a year ago, I presented the most common usage of Helidon, and now we will actually go a little bit deeper, and we will explore really like big possibilities of it. So let us actually start. So just for you who don't know, so what Helidon is, so it's a library for developing, framework for developing microservices. As Helidon, I really like his name, is called by the name of swallow. So a small bird really flying somewhere high in the clouds. Perfect name for something which is quick, maneuverable, and in the clouds. So it's makes it unique in infrastructure of Oracle is that it's open under Apache 2.0 license. So it's one of the first products of Oracle which is under this license. So it's all the code is available on GitHub, and you just go there and see. So we accept PRs, as we usually say. Build on top of Netty. Cloud native ready. That means that you don't only just serve your microservices, but you also have everything with them, like REST, metrics, health tracing, everything you really want and need. And we have one of the best in class, I would say, GraalVM native image support, because I will actually show it a little bit later. So 99% of our code is GraalVM native image friendly. And as I say, what are the numbers, just to give an impression. So we're really small, and as you see, we provide 3 ways of shipping the product. That means that you can just do normal jars, which are executable jars. You can do Helidon native image of, GraalVM native image, and there in the middle you got this native, not native, but JLink custom image, which custom image is cool because we are modular from the very beginning, and you just throw away all the code you actually don't need, which is good. And that's why you get better startup times, less disk space usage, and as a result, it works even good. So if we take a look at the architecture of Helidon, so we are built on top of Netty, and Netty itself is asynchronous engine, and on top of it, we actually bring this Helidon Reactive or Helidon SE product, which is actually wraps Netty and provides you all you need to run your services in the clouds, and make it in a reactive way, in a completely reactive way. And on top of it, so we discussed that the connectivity, not connectivity, but portability level of Helidon will be under microprofile. So let's actually jump a little bit just to see you. And as a result, you have 2 flavors. That makes the product quite unique. So you can write a code with annotations, like guys from Spring. Just give a bunch of annotations, and it somehow with magic will work. These annotations are provided by the microprofile specification. Other ways, just write pure Java and make it pure reactive. So as a result, you have a very, very small footprint. Pure Java, there's only one annotation used, which is override, so we don't use any other annotations, and this is it actually. So 2 flavors, and if we jump into Helidon MP, it's actually based exactly on this microprofile specification, which is a set of specifications especially designed for a microprofile. So we have Ottavio here, by the way. He's very active in microprofile. So thank him for actually doing this for us. And when I say specifications, the specifications means that uh, it's not a code, you just implement the code. And Helidon is one of those who actually implement it. So they're all designed to run in clouds, so in a distributed world of microservices. That means you have tracing, you have fault tolerance, metrics. For security, you have JOT. You can check um, the you can also, how I say, port the configuration with config. So whenever you have like other product who is capable of microprofile, just drop in the code you have and it will run because it's standard. We even get even more than that. So it's not only microprofile that we support. So there are also a lot of Jakarta E specifications, or something which runs under MP umbrella like GraphQL and LRA. Once again, that means that you just drop in this code and it works because it's portable, because it's standard. So we really care about standard. And what makes us also quite unique is that we are able to run full CDI. We have full CDI support, and it is also done. It can be compiled to GraalVM native image. So whenever you do something in CDI, so it will be GraalVM native image friendly, so you can create it, which is cool. But once again, all of that stuff is blocking. Blocking means that you run synchronous code, and as you run synchronous code, well, the threads are blocked. So it's just blocked and it's waiting. So for that, if we go back to the slide of architecture, you see this Helidon reactive. And this Helidon reactive, for us, we even call it the danger zone, just because you get all the same functionality as you have in MP, but you have it in asynchronous reactive manner. And even more, you even get this reactive web client and DB client I'll be talking about later. So all the same stuff, but all running reactive. So as a result, the smaller memory footprint, there is no magic which is done by CDI. Just pure Java, and that's why the memory footprint, the disk usage is really, really low. So we've been playing with some guys from the GraalVM native image team. We were able to establish a web service, a REST service, which has client, DB client, and web client, and it all was 10 megabytes of space actually used. The executable, pure executable, was only 10 megabytes. So awesome in this part. But as I say, going reactive with Helidon, just a small reminder of what reactive is. So once again, it's very small, and there are a bunch of talks about it, how you should do this, but just to give you an impression. So once again, as we get a lot of data, and a lot of data has to be processed, so we're trying to reuse as much as we can from every thread, actually. So for that, actually, I made a talk a few years ago about thinking async back into Java 8. So it was a talk, I think, recorded on Devox. So when we tried to actually solve the problem of this callback hell as much as possible, and we were able to actually reuse as much as we can the threads that we have. And with this completable futures and all of that stuff, we were able to really, really write code which was asynchronous, and this way we used a lot better the resources that we have. But as everything has revolved, so we came up to the idea of reactive computing. So, and this reactive computing came up with this paradigm that everything can be expressed as a data stream, actually, and a propagation of change. So that's why you just have arrays are like more like data, like static arrays and dynamic arrays are like more data streams. So that's why we facilitate the propagation of change as data flow. So it's I would say not exactly continuation, but like, a way to describe uh, the paradigm of this programming. So it has its reactive manifesto. Everything has a manifesto right now. And once again, we all try, we have seen this picture many times. So we try to make the code responsive, resilient, message-driven, and reactive. So this way we facilitate the idea that we reuse the resources as much as we can. So the best explanation for me personally was given by Venkat Subramaniam, as he said, like we have three flows of things happening. So we have a data stream, which is actually our data. We have an error stream, which something happens. We can react on that gracefully, and we can just say, okay, so is it done or it's not done? So the data comes something just non-blocking flow of events. We have a control of what's happening there with the events, and we adequately can react on errors. So, and as a result, we come to the idea of this reactive streams. So, once again, an initiative that provides the idea of a asynchronous stream processing with, once again, not blocking back pressure. So the idea of something which is non-blocking and asynchronous and provides us a back pressure so that if, for example, the consumer cannot consume anymore, he's able to tell about it. So with this paradigm, we actually came to a very, very effective processing of the data that we have. And once again, as I started from Java 8 with this completable future, in Java 9 we have these 4 APIs, flow APIs, which actually provided some kind of a combination between iterator and observer patterns with the subscriber, publisher, subscription, and processor, which stands underneath, not underneath, in between. And once again, we have something that publishes information. We have something which subscribes to this information, and processor underneath. So, and all of that, the link between publisher and subscriber, is called subscription. And this way we can organize really, really, I would say, powerful way of processing the data. So, and as a result, several engines actually appeared, and we quite good know them. So first one, RxJava, of course, Akka Streams. Spring Reactive project is very famous. Unity by Parker's guys. So I think that there were talks here as well. Even Apple joined with his service talk. But we also have our own engine, Helidon, and I'm going to tell you actually what it is and how it is, and why it's actually interesting to have really something which is so underneath everything, so is a foundation of everything. That's what. How can we achieve really big results here? So, Helidon Reactive Engine. So, as you remember this picture, we have this Helidon SE, and this Helidon SE has its own set of reactive operators. We don't use anything from outside. So we only use this Flow API. So we're based on this Flow API, and we can provide two main classes that help us. This is the multi and the single for streams. So what you have to do is only to include this dependency. So we are Maven Best, and you just have the engine that you can use. So if you remember Spring, the Spring itself has this Flow API, not Flow API, but Flux and Mono. We use multi and single in our constructions, and we have, as you see, just multi with multiple elements and single with one element. And as a result, we have a very big amount of our own reactive operators to actually work on the flow of the data and to transform it the way we want. So we just create, for example, a multi. We can create a processor to process it, and then we finally publish it somehow. And quite good is that we are comparing to other frameworks. We are very fast. So they have some GMH measurements. Helidon really provides a very fast method for that. And now, as we have this engine, by the way, we're quite proud that it was contributed by David Carnham himself. So he is the creator of the reactive paradigm, one of the fathers. So he contributed it to us. So our own reactive engine makes us really no external dependencies, just pure Java. And as a result, we have our own reactive web server. So that means that the server, once again, it's non-blocking, fully reactive, and it's pure Java. So as you see, just create a class, build it, start, and it will deliver you, it will deliver you a full power of reactive way of processing data. So just to show you a small demo, how easily you can start a Helidon SE project. So we have our own Helidon CLI. So we can just download it. It's an executable file. By the way, it's written also in Java, and it's compiled as a native image for other platforms. So only pure Java. And we do all this Helidon init. So maybe in childhood, so we created some kind of a test or something, which you answer several questions. So you just answer several questions that we want a Helidon SE quick start project. And we just say, what is the project name? What is the group name? What is the version? Should we make a development loop so it can look up all the changes for us? And it creates us a project, so it's Quick Start SE. Because we don't have much time, I want to demonstrate you more things. We just open it. So idea, Quick Start SE. Yes, okay. So a lot of things to show. And as a result, you get a fully functional project which actually works as pure Java. And it's fully reactive. So, just, I hope you can see it, or should I make it a little bit bigger? So the code, I will just make it bigger. Or, funny thing that the IDEA does not handle it. But it's so small that it could just have one main file, and that's it. And as you see, the server itself, it's just a single observer. So single, that means it's something that will come in the future. So it's one element that is reactive. And all the work with server is done in a reactive way. So when the server is started, then we can just accept that it started and see that yes, so this is server, it's working. If it's something is wrong, there's another flow event happening, yes? So we can just say, okay, service failed. So once again, full control and it's full reactive. So that's why we have our own this set of operators and our own set of constructions to write everything in a reactive way. Here it just sends a greetings to all of us. Very easy. One function you actually have to do is just to overwrite one function of a server interface, and you just get the request and response, and non-blocking way of serving your microservices, your actually REST endpoints. Yep. So it's so easy that I hope it will just start like a usual main file, very fast. And if we go to terminal and type something like curl, what was the last one, like greet. Of course, it's so easy, but we can just greet Portugal. It's my first time here, so we can once again query it, but out of the box you get more than that. Even if it's reactive, we can not read, but just get here health. So we can read health checks and metrics. So that means that the server not only serves you some data in an asynchronous reactive way, it also serves you how its health going, what are the metrics we are reading, and it's once again it's all fully reactive. Yes, so as you see, very fast. It starts out of the box. There is no magic that you usually get from all this CDI stuff, and it works pretty nice. I will show you, compare you a little bit later how it works with some new features that we have just added. So, as I said, very quick, very fast, and this is exactly the reactive way of doing this stuff. So once again, not going too much into details, just because we are quite limited of time, and I just wanted to show you really more things here. As I said, so with the reactive messaging, a new project was actually formed called Microprofile Reactive Messaging, as once again the idea was to reactively send and receive messages with supportive back pressure. And of course, that should have been an acknowledgement abstraction mechanism that to say, okay, is the message received or not? Should we do something with the back pressure or not? And it is designed as a pipeline, so you can easily connect different APIs there. So the messages themselves are so much abstracted that they can go through absolutely different engines. Should it be Kafka, AQ, and so on and so on. So just with few annotations, you say where should the messages go. You just do, like, for example, this several messages should go to something named AQ. Yes. As you say, you can do it either with reactive way, as you see here, just to publish it, or with not exactly just publish them as a stream, or you can just do a multi of them. That means that in a reactive way, that will be consumed. You can just even use third-party APIs, which makes sense. So we just RxJava fallable, or you can even, if you have Reactor on board, you can just say flux of it. So it will all go and will be processed. The same here is about, so we just have the emitter, you emit these messages, and there should be a consumer. Consumer should be annotated just with incoming, and as the messages comes, it just somehow consumes it. We can make, yes, you can read more information about this on microprofiles. Once again, we are caring for the specifications, and if you have this, if you follow this specification, it's quite easy. So that's why I call it like 0.25 of my presentation, just to say that based on this specification, we have made our own Helidon reactive messages. So that means that based on this interface and based the way how it's formed, we have created our own implementation using exactly reactive operators that we do have in Helidon. And this way, just with one dependency, you have all this reactive engine which is on board, has no other dependencies on them, and reactive APIs to work with these messages. So we have a publisher and a subscriber, and as a how we say, a logically connector of them, we call it channel. So it's you publish a publisher as subscriber, and in the middle you can put a processor, and all of that is completely reactive. So that means that you just create a channel. You just say what the publisher is. As you say, it's reactive, so multi of something. And you just put a listener who actually, whenever a message gets intercepted, you print it out. You can put a processor in between to process your data somehow. So for like processor, it becomes a subscriber for upstream and a publisher for downstream. So you can put as much processors if you want. So just create several channels here, get a publisher, some reactive stream of something, a processor which does uppercase, for example, and as you see, just subscriber who prints the messages. So it's very easy to create these big pipelines of reactive data processing with back pressure mechanism support. So as a result, we took the microprofile as an idea, as a specification, and we just get away all the magic that is there happening with all the CDI, with all these injections, and it's become a pure Java, I would say no magic philosophy that we use in Helidon SE. And we have different connectors, so that means that the messages themselves can go not just from the memory, you can go through Kafka, through GMS, from AQ, and actually our socket, so a special protocol designed for reactive communication. So it's all going to go in through different, I would say, medias. And once again, Helidon has full reactive support in that. Actually, before going to reactive goodies, let me show you a code. It's quite easy code. I will open an example. Once again, just the main method who has, as you say, the server start. So it starts reactively. Whenever it's OK, we print that it's OK. Whenever something is wrong, we'll get this exceptional channel. We say that, yes, something has failed. And now we want to transmit some messages via Kafka from one client to another and push them via WebSocket. So as you said, we create a channel to Kafka, which actually pushes the messages to Kafka. And very, very easy connector. So Kafka connector, which is set up via just a YAML file. So okay, listen to Kafka at that port. By the way, we are very grateful to IntelliJ guys that give great support for Helidon in our own tools. And we, this way, send the message to the channel, which is actually Kafka. I think that we do have some processing. Actually, no, we don't do anything like process here. We just send the message. We emit them with the emitter, and this emitter connects to Kafka and pushes the messages there. On the other side, we say that, for example, we want to push these messages to our clients via WebSocket. So we create another channel from Kafka and consume the messages from a special group ID, is here, and just push them to our clients. So it's extremely simple, but you see, just with these two abstractions, you're able to get real data streaming, I would say, engine in a fully reactive fashion. So if you don't mind, I will just run the Kafka. So you see, it's always a good idea to not update your Docker before conferences. So I hope it's ready. And now, if we go here, I will just do Java -jar target run. Just the WebSocket jar application. It starts extremely fast, and it's pure Java now. By the way, it's not even the native image. So if we put a message here and we submit, it goes through Kafka and then pushed automatically back to Helidon via WebSocket. Hello, I would say Coimbra, for example. Yes, Coimbra. I think I missed this. And as we said, yes, through Kafka it goes, the channel, just with two abstraction, everything is reactive, and the server itself works reactively, makes it very, very easy and fast. Okay. So just to give you an example, by the way, this example is completely official. You see it emits the messages. Kafka says, this is a message I just came there. It's official example. Whenever you play with Helidon, you just run the code and you have the examples available. I will switch that off because we don't want some ports to be like used sometimes. But there is one thing. So once reactive, you have to be always reactive. And you can't do synchronous code in the middle of reactive and asynchronous code. So we have provided another thing to our clients, which is called we can consume the data from the database in a synchronous way, although the drivers themselves can be synchronous. That means that we have created a special driver, or wrapper of the driver, which actually works with the code, with the database, in a different executor and provides you a reactive way of working with the code, with all the singles, multis, and reactive operators that you've seen. So no matter what the database is, it will run in a different executor. And as it runs in a different executor, it will work reactively for you. So you work reactively with the database, although it may block somewhere in its own executor. So another way is if you not only produce data in reactive way, but if you consume data in reactive way, there's another reactive web client. So once again, it reads everything with this multis and singles. That's why you can process the data reactively. But I hope I didn't lose you, so I see only 3 people sleeping right now. Yes, reactive is cool. Reactive is interesting. The code itself, you see, it's a pure Java. It works. I'm not much into details here, just because getting too much into details, you can just simply read it in the documentation. That's not interesting. But what if we don't like this style of coding? What we want to do is just a normal Java coding, and it's typically blocking. Here comes something that you probably may heard of for the last 10 years. And it's called the project Loom. And I'm so much happy that finally it's not just a research project about virtual threads. It's a real JAP 45, which came like about a month ago, several months ago. It's 05, yes, it's a month and a half ago. And it will finally bring it to our own and great JDK that we can use it. Not only play with it, but really use it. Maybe for now as a preview feature, but it will come to us. So what is the main idea? You know that the threads are very important and very, I would say, heavy resource. That means for every thread you have to create about 2 megabytes of information, just describing the thread, carrying all the context that actually is required to run the thread on the operation system thread. And running a lot of threads is a bad idea. So on big machines, you really can't get up to 400 threads, as far as I know. So that's why they created those virtual threads. Those virtual threads are API-wise absolutely the same as real threads, but the virtual machine takes care of actually managing them. So virtual threads are mounted over carrier threads. And if something is blocked in a virtual threads, so the virtual machine understands it, and using a continuation API, which is not external, it unmounts it and puts something else to work, making room for the others, actually. Once the JVM understands that, or the scheduler understands that, okay, the virtual thread that was blocked is not blocked anymore, it will just mount it on a real thread and let him do his job. Yes, fork join is used underneath, and once again, for us, as developers, these threads are API absolutely the same wise. So currently, you can already have the access built, so you can already download the JVM with JDK with this virtual threads possibility with Project Loom on it. And once again, the threads are now not a big resource. They're not a heavy resource. You can have millions of threads. They really don't block, I would say, real threads. It's happening somewhere underneath. And what's the best part of this? The API by threads themselves. So there are just some additional methods for the executors, like you can really create virtual thread executor, or you can see if the thread is virtual or not. So, in Helidon, we understand that this is good, and only with actually one property, or actually two properties in our case, we can run our threads, the threads which care for requests, in virtual executors. So it's really, really easy. Um, in Helidon NCA, you don't need it because it's not blocking anyway. But only with one property, you can just change everything. And as a result, we have a small demo prepared by Thomas Langer, our architect, just to demonstrate you it, how it really works. So if we have two endpoints, which is slow, making long blocking call to DB or something, and quick returns immediately, and if we run them simultaneously, the long operation blocks the threads, so they will just block everything. And for quick operations, there will be no resource, and they will just break with timeout. And that's quite a usual situation. So how usually people care about such an event? As we say, giving more threads is not a good idea, because you cannot extend infinite. You can rewrite everything in a reactive way. As you see, Helidon provides this possibility to you, and it's okay. It's Java. You have a little bit to break your head with these reactive operators, with these multi-singles, and so on, and you will get a better performance. Definitely, you will. Or you just can switch one property and enable virtual threads, and the performance will just burn. And actually, let's see if that's true or false. So, I have created, no, not I, our colleague, uh, Thomas Langer has created a small demo, which actually demonstrates this idea of, we have two endpoints. I will here show you blocking way of doing it. So, in microprofile, slow endpoint which just sleeps for 10 seconds, and a quick endpoint which just returns the immediate result. And we have two clients. The clients are a little bit sophisticated as they track how many requests and response there are. No need to jump into this code. Once again, main resource with slow and quick endpoints. The very same is written in Helidon Reactive Server. By the way, just take a look how small code is actually here. So you just have a web server which you build and start. So you'll just a single, you'll wait when it starts. You block here. And this server is also has just two endpoints, quick that return the result, and slow. Here's some tricks, by the way. So as we are reactive, we can't block, so we just play with one scheduled executor, and we block for a certain amount of time here in this executor. And let us actually see, if we run all this stuff, how it happens. So I will go to console, and I have created several windows for that. Let me just start it. So window group, which is for JNation. And what we have here. So to just enable everything, we have to switch to JDK 19 everywhere. So it's my shortcut, JDK 19. We switch to JDK, which has this Loom support. JDK 19. And yes, here, JDK 19. I hope the demo goats are with me today. Just to control, we don't need this anymore, just to control the way the code actually using Loom or not using Loom, we have two properties, as I said. So if we jump to the server, the Loom just says, okay, server, enable virtual thread true and enforce them, so to be sure that only virtual threads are used. And for non-Loom, we just say false. And that's it. So only with one variable, actually. We control, should we use virtual thread or should we not use virtual threads? Okay, now if we start the server, I would say first no Loom. It will start as quite a regular Helidon MP server, which is blocking, which is just a microprofile implementation. And here we will run a few JJS, a few code examples that are target for slow client. This will, not JS, but JJ, which is short for Java minus jar. It will start sending requests and responses. At the end, you see 10 requests sent and 10 responses are returned just because we are sleeping there. If we put a fast client here, so target, then what was it? Yes, quick. We will see that actually we're getting errors, which is completely expected here. So that means that the long requests are served. The quick request simply cannot, force this through this barrier of no threads left. And as you see, the result is quite nasty. Good. So this is a blocking way. So I'm just now switching it. And now the very same stuff is done with reactive. So this reactive Helidon I was talking to you, that with Reactive Engine and reactive messaging, reactive operators, we just run it, and suddenly you see something interesting happening. You see long threads, long polling threads are blocking, but the quick threads are still getting their response. So that means as we are not blocking, we can process much more and much better. You see 27,000 requests are being processed, while the threads are actually blocked. So as you see, just rewriting everything in reactive can change our life drastically. Yes? You see, just see it with your eyes. I'm doing a live demo here. And good. Nice. So rewriting everything with reactive, even in terms of Helidon, may actually unleash very powerful resources. Now we stop it over. But once again, we are enterprise developers. We don't like breaking our hands with reactive. Yeah. We want some magic to happen and everything suddenly to start work. Well, let's do this magic. So we will say something which just with one variable changes the executor to virtual threads. And here you can see the magic actually happened. So it's very same code in Helidon. It's absolutely the same. It's blocking code. But as we put it through virtual executor, suddenly the quick requests become like responsive. You see, just with one property, you see as the virtual machine gets warm and warm, you get better and better performance. So Loom actually changed our lives, or will change in the next release. Or at least change the life of many enterprise developers who just wanted magic, and this magic to bring a lot of productivity to them. But you still see that we were getting there 27,000 requests per second. Now we're getting less than that. So still reactive, or reactive style of coding may beat, I would say, blocking way of coding, and be more performant. So this is actually the live demo. I wanted to show you this. Let us stop everything. As you see, one property only switching the threads from real to virtual gave us really awesome performance. So what actually Loom help us? So it's easy to write, so you don't even probably will need to rewrite anything. Subjects may change about this performance, so it's still in progress. But performance is really close to reactive when you need to break your brains for that. But reactive is still faster, or at least to these experiments I showed you. And here we come to another thing that I wanted to show you, is that we see this potential of virtual threads, so that's why we created something we called Nima. So it's a project to some kind of replace this netty layer that we showed you on the Helidon architecture. So we have a Loom-based web server, which have all the support for HTTP, 1.2, gRPC, WebSocket, MTLS, and all of that stuff. It still has all this access log, course support, everything actually you need, with even more things coming. So OpenTelemetry is already there. Observability endpoints are already there. But the main idea is that it's fully blocking Java code. We used virtual threads, this enhanced switches, sealed classes, and logger. For us to create a server which is absolutely only JVM dependent. So that means unlike Netty, here we don't actually have anything which is specific for a platform, and we still get even better results. And this only actually works on a JVM. We don't have some kind of a platform-specific code as it's usually done in Netty. So in Netty you have a lot of magic. And yes, so that was just a little bit dive into the future. So as you see, this thing is on its way to be open sourced. So we haven't chosen a name, as you know, Nima. So it's about to be open sourced. And once again, it's a blocking implementation based on especially Loom. So we hope that Loom will come soon, and you will see. For you who wanted to try Helidon, so as you see, you have blocking way of doing things and a reactive way of doing things. You can just follow us on these links, which are Helidon project is where we publish everything. If you want to talk to us, you can use our Slack account. We publish videos, we publish articles. And yes, reactive is awesome. As you saw, as Helidon has its own reactive engine, you don't need any other dependencies. If you understand how to write the code, you'll get a lot of performance. But quite soon, for those of us who don't want blockings, don't want to rewrite our code, there is blocking. And if Project Loom comes quite soon, I believe maybe in year 2, the blocking code is also an option. So with this, actually, I wanted to say thank you for listening, and you may try it in Helidon. So Helidon is really cool because it provides you actually this playground, all in one, to play in blocking and a reactive way. So thank you very much. Yeah. Questions?
Yes, we have questions. The first one belongs to Ambus Sampath. Hopefully, you say your name correctly. Is Nima open source?
As I say, it's about to be open source. So we're working hard on that. So it's going to be open source quite soon. Yep.
By the way,
in GitHub, I think.
is there somebody
Apache
with questions?
2.0 license.
Please raise your hand. Okay.
Just
please.
The microphone, yes.
She's running, so she's not reactive. Sorry for that.
If she was reactive, she would not run. She will just fly there. Yes, almost there. Thank you.
Is it?
Yes.
Thanks. So she was fast enough. I was saying that you've shown us Reactive and Loom, Project Loom, and they're both quite performant. And from my personal experience, I've already tried reactive streams. But what about debugging? What is your experience with that? Because for me, it was quite a nightmare, almost like I had a stroke trying to debug a reactive application versus a regular classical synchronous one.
Well, from my experience, debugging is not included in reactive.
That's my point.
Yes, so you just have to write correct code from the first time.
Ah.
Yes, you see, they pay us for writing correct code, not for bugs. And yes, I completely see your pain. I know what it is. Debugging is a nightmare, but it's a paradigm. So once again, You have these three streams of things happening: data control channel and error channel. If you're able to use them, like to pass your data there, good. But this is the problem of the paradigm itself, at least at my point of view. Maybe I'm wrong.
Okay.
Okay.
Thanks.
Okay, is there any more questions? I get another one here. Is there any plans to have support to HTTP 3?
HTTP 3 was released like, several days ago or several weeks ago.
Yes.
Yes, most of the people don't even use HTTP 2. But we are working on HTTP 3. At least we are estimating it right now. Estimating, I would say.
Okay, it's coming, so be patient. Is there any more questions for the audience? Is more questions from the internet? No?
Speechless.
Okay, if you raise your hand, it'll be so fun because she needs to run away to you.
No.
Okay, give once. Give twice. Come on, guys, we have time. No?
No, it's written. Time is up.
Okay. Thank you, everybody.
Thank
Again,
you.
Dmitry. Thank you.
Yeah.